Hi everyone, in this video I'm going to describe a very important subject which is one of the most important topics that almost search within the science and research area, means machine learning. Maybe you are not a computer science or engineer, but you want to learn and know what machine learning is. So if you are going to learn machine learning concepts very easily and have a fast review about them, in a very simple and easy expression, you should continue to visit the remainder of this video. Before I start to explain what the machine learning is and what is its paradigms and algorithms, we should know where does it locate in the science and what other concepts we are engaged with. As you can see in this figure, machine learning, which is displayed with a green color, is a subfield of artificial intelligence, which is completely located within the artificial intelligence. Okay. And deep learning in the blue color is a part of machine learning as the same. All of these have overlap with data science, so this figure wants to tell us that if you are going to learn machine learning deeply, you need to have a good knowledge about artificial intelligence and data science also. As I told you before, because I want to teach machine learning very simple and brief, it would be out of the scope of this video if I want to explain all of them. So I just check the definition of them briefly. Okay, let's see what the machine learning is, or what is the definition of machine learning. Machine learning is a subfield of artificial intelligence concerned with the implementation of computer software that can learn autonomously. So the goal of the machine learning is to design or develop a computer software that can learn autonomously, which means without human intrusion, for an artificial intelligence product or field. Okay, this is the definition of machine learning. So data science here can be seen as an umbrella for all the disciplines used to make sense out of huge volumes of data. Data science research is a foundation for building smart artificial intelligence products, whether they are machine learning based or deep learning based. And the artificial intelligence is about creating a functional data product that can solve set tasks by itself, which remotely resemble human problem solving. In fact, it is a study area that allows human intelligence to be imitated by a computer. So in the artificial intelligence, we are going to make a human-like powered computation in a software. Okay. So let's see why you want to learn artificial machine learning, or in other words, what is the application domain of machine learning? Why we need to learn the machine learning? There are so many application domains. I just bring here some of the most important one of them. Financial service. For example, in the financial service, we have portfolio management, we have algorithmic trading, fraud detection, risk management, trade settlement, money laundering prevention, loan or insurance underwriting. And in marketing and sales, we have faster customer service, smart content creation, easier marketing automation, optimized advertising, powerful social media management, automated email marketing campaigns, and government, which is a general topic, can be divided to some small topics. There is social welfare, domestic security, military, education, emergency, oil and gas, which is a part of energy. Within the healthcare, we have identifying disease and diagnosis, drug discovery and manufacturing, medical imaging diagnosis, personalized medicine, and smart health record. And in the transportation, which can be located in the government, we have smart cities, traffic management, smart parking, accident prevention, emergency vehicle routing, home and safety. Okay, now let's see what is the machine learning paradigms. Okay, let's check it. We have three main paradigms here: supervised learning, unsupervised learning, and reinforcement learning. And the description, very short and exact description for them, I bring them here. In supervised learning, is the computer is presented with example input and their desired outputs given by a teacher, and the goal is to learn a general rule that maps input to output. So in the supervised machine learning, we are going to find a general rule that, in fact, we have a specific problem. Let me explain like this. We want to find a general rule that we can use when we solve the problem, we can use to another problem. It is some generalization. Okay? And the data has labels, and we know what is the desired output. Okay, in unsupervised learning, no labels are given to the learning algorithm, leaving it on its own to find structure in its input. It is somehow like discovering hidden pattern. Okay, we don't know how many cluster or how many class or label we have for our model. And reinforcement learning is a computer program interacts with dynamic environment in which it must perform a certain goal. The program is feedback in terms of reward and punishment as it navigates its problem space. If I want to give it by an example, in robots, for example, in robot pathfinding, we are going to find a task, and if a robot could find a task, it would be feedback in terms of reward, and if it couldn't find a task, it would be punishment. It is a very small example of reinforcement learning. So let's see. Let's review the supervised machine learning. Supervised machine learning is best understood as approximating a target function f that maps input variable x to an output variable y. Or the equation is y equals fx. Okay, this is a mathematical definition. And let's see, we have two kind of techniques in supervised machine learning. We have regression technique and classification. Okay, what is regression? Regression is performed when the dependent variable is of continuous data type. An independent variable could be any data type. Regression methods try to find the best fit line which show the relationship between dependent and independent variables and predictors with least error. And the classification refers to a predictive model problem where a class label is predicted for a given example of input data. Let's get deeper into them. Okay? So in the supervised machine learning, we want to check the regression. In one category, we have simple linear regression and multiple linear regression. We are located in the linear regression. We also have a nonlinear one. Here in the linear regression, let's see what is simple linear regression. Equation for best fit line is y equals a plus bx. Y is dependent variable, x is independent variable, a is intercept, and b is coefficient. So in order to predict y, for example, here we have salary, y for our dependent variable, given the x age, we need to know the values of a and b here. For example, we want to approximate the salary based on the age. Age means its experience. Okay, how much the person is experienced, the salary would be more. Okay, as you can see in this chart. Okay, while training and building a regression model, these coefficients learned and fitted to training data. The coefficient value can be calculated using gradient descent method. Okay, so we know what is the y and what is the x. We should just train the a and b, coefficient and intercept, to take or get this line, this regression line. So this was a simple linear regression. Example, in multiple linear regression. In the multiple linear, the independent variables are more than one. Like home price prediction. For example, you want to predict the home price. We can have some factors. The price depends on the number of rooms, closely goes to subway and shopping places, area of homes, location of home, and etc. So, in the multiple linear regression, our independent variable is more than one. Okay, let's continue. As I told before, we have nonlinear regression, or called polynomial regression. Transform the original features into polynomial feature of a given degree, and then apply linear regression on it. It is still a linear equation, but the curve is quadratic rather than a line. The mathematical equation would be something like y equals a plus bx plus cx power 2. As you can see here, it is not linear. It is nonlinear regression. In the y-axis, we have tumor rates, and in the x-axis, we have pesticides. It would be something like this nonlinear regression. We also have logistic regression, which can be categorized into classification. It is in fact a binary classification. Let's see what is it. It is a regression model where the dependent variables categorical. In fact, it is a kind of binary classification which our class has two types, yes or no, true or false, negative or positive, like spam detection. For example, in an email spam detection, we want to check that is it an email, real email, or it is a spam. It is categorized into logistic regression and also called binary classification. Okay, now let's check what is the classification. In supervised machine learning, the placing of a sample and data in a series of increasingly specialized groups because of similarities in structure, origin, etc., that indicate a common relationship. This is a definition of classification. If I want to explain it by an example, for playing a tennis based on temperature, wind, humidity, to see that whether it would be raining or not for playing or not playing the tennis game. Or another example is a car classification based on its price, safety, its speed, number of doors, and etc., which can be classified into bad cars, medium cars, and good cars in one category. Okay, now let's see what kind of techniques or algorithms we have for classification. The first and the most important one is decision tree. It uses a decision tree as a predictive model to go from observations about an item represented in the branch to conclusion about the item's target value represented in the leaves. Tree models where the target variable can take a discrete set of values are called classification trees. In this tree structure, leaves represent class labels and branches represent conjunction of features that lead to those class labels. Decision trees where the target variable can take continuous values, typically real numbers, are called regression trees. Okay, it is a decision tree method. We want to know, should I write this blog post or not? Okay, let's check it. Do I understand the concept? If it is no, so study up more first. And this is leaves. As you can see, it's our class. We have a yes, no, or binary classification here. As you can see, it just makes some decision by dividing them. As you can see, we have leaves here. The red color is no class, but the green one is the yes class. As you can see. Okay. Let's check what is the pros and cons and applications of decision tree. First, the pros. Normalization or scaling of data not needed. Handling missing values means no considerable impact of missing values. Easy to explain to non-technical team members and easy visualization. Automatic feature selection, which means irrelevant feature won't affect decision trees. So let's check the cons. It's prone to overfitting, sensitive to data. If data changes slightly, the outcome can change to a very large extent. higher time required to train decision trees. So it means decision tree is a lazy classifier. And application domain would be identifying buyers for products, prediction of likelihood of default, which strategy can maximize profit, finding strategy for cost minimization, which features are most important to attract and retain customers, and fault diagnosis in machines. Okay, let's review or check the second algorithm or technique. It is naive-based. It is based on Bayes' theorem with strong or naive independence assumptions between the features, which is one of the simple and most effective classification algorithms which helps in building the fast machine learning models. Just pay attention to here. It's a fast machine learning model that can make quick prediction. So if you want to have a quick prediction for a problem, it would be very useful technique. It predicts membership probability for each class, such that the probability that given record or data point belongs to a particular class with the highest probability is considered as the most likely class. As you can see, this is a naive-based sample here. For example, in this, these are data points. As you can see, this data point probability has been calculated. So it's located in the red class here, as you can see. And let's check the pros of naive-based technique or algorithm. It is very fast and can be used in real time. It's scalable with large data sets. Is sensitive to relevant features. Multi-class prediction is effectively done. Good performance with high dimensional data. And let's check the cons of it. Independence of features does not hold. Bad estimator, which means probability outputs from predict proba are not to be taken too seriously. Training data should represent population well. And application area would be text classification. It can predict on multiple classes and doesn't mind dealing with irrelevant features. It can be used in spam filtering for identifying spam emails, sentiment or sentiment analysis, feeling analysis, in fact, in social media analysis to identify positive and negative sentiments, and recommendation systems. What will the buyer would be next? Buy next. What will the user buy next? Okay. In the third technique or algorithm, we have support vector machine or SVM as brief. The objective of the support vector machine algorithm is to find a hyperplane in an n-dimensional space. N is the number of the features that distinctly classifies the data points. As you can see, we have a hyperplane here. These are data points. We have two classes here, green and red classes. As you can see, it has been separated very well. Our objective is to find a plane that has a maximum margin. You can see the margin we have here from this dotted line to this dotted line. We have margins here, as you can see, and it should be maximized. For example, if we want to do it from here to here, it wouldn't be maximized. So we want to have a maximized margin hyperplane. This is our goal. Our objective is to find a plane that has the maximum margin. In example, the maximum distance between data points of both classes. Maximizing the margin distance provides some reinforcement so that the future data points can be classified with more confidence. It can be used for classification and regression problems too. Okay, let's see what's the cons. Performs well in higher dimension. Best algorithm when classes are separable. Outlier have less impact. Is suited for extreme case binary classification. And for its cons, we have it is a slow model, poor performance with overlapped classes. Selecting appropriate hyperparameter is important. Selecting the appropriate kernel function can be tricky. Application domain would be bag of words applications in many features and columns. Speech recognition data, classification of emails, nonlinear data, medical analytics, nonlinear data also, and text classification with many features. So we are still continuing classification algorithm and techniques. The fourth one is k-nearest neighbor, or KNN as grid. Can be used to solve both classification and regression problems. In both cases, the input consists of the k-closest training example in dataset. The output depends on whether k and n is used for classification or regression. An object is classified by a plurality both of its neighbors, with the object being assigned to the class most common among its k-nearest neighbor. K is a positive integer, typically small. If k is equal 1, then the object is simply assigned to the class of the single nearest neighbor. Kn is often used in simple recommendation system, image recognition technology, and decision-making models. It is a slow model. As you can see here, we categorized into red and green classes here. We have a data point here, which we want to determine using k and n. Okay, if we consider k equal 1, the nearest neighbor to this is red, so it can be located in the red one. But if k is more than 1, for example, if you want to classify with k equal 2, 3, or 4, it would be, for example, here it's circle 5, which means it chooses the circle, it chooses k equal 5. So as you can see, nearest, 5 nearest neighbors are these ones. So because the plurality vote is 3 to red, so it can be located in the red or category 1 here. Let's see the process of k-nearest neighbor. Simple to understand and implement. No assumption about data. Constantly evolving model means when it is exposed to new data, it changes to accommodate the new data points. Multi-class problems can also be solved. One hyperparameter, which means k and nearest neighbor, might take some time while selecting the first hyperparameter, but after that, rest of the parameters are aligned to it. And let's check the cons. Slow for large datasets. Curse of dimensionality problem can be encountered. Scaling of data absolute must be done and does not work well on imbalanced data. It is sensitive to outlier and can't deal with missing values. And the application domain would be, you can use it for any classification problem when data set is smaller and has lesser number of features, so that the computation time taken by KN is less. Okay, let's check the fifth technique or algorithm. We have random forest classification, which is using ensemble learning. Is an ensemble learning method for classification, regression, and other tasks that operates by constructing multitude of decision trees at training time and outputting a class. Ensemble methods are machine learning methods for combining prediction from multiple separate models in order to decrease variance, which bagging method, bias, which is boosting method, or improve the prediction, which is stacking method. In bagging, it trains a large number of strong learners in parallel. Strong learners is a model that is relatively unconstrained, and bagging combines all the strong learners together in order to smooth out their prediction. The boosting method trains a large number of weak learners in sequence. The difference is strong learning parallel, here is weak learning sequence, and weak learning is a constraint model. Each one in the sequence focuses on learning from mistake of one before. So boosting combines all the weak learners into a single strong learner, and stacking that often considered heterogeneous weak learner, so it is a weak learner also, learns them in parallel. So it is a weak learner which is in parallel, and difference with boosting is here, and combines them by training a meta model to output a prediction based on the different weak models' predictions. In fact, random forest models are a combination technique multiple classification technique has been used. So let's see the process. It has reduced error. It has good performance on imbalanced data sets, handling of huge amount of data, good handling of missing data, little impact of outliers, and no problems of overfitting, useful to extract feature imbalance, feature importance. We can use it for feature selection also. And for the cons, we have features need to have some predictive power, else they won't work. And prediction of the trees need to be uncorrelated and appears as a black box, which means you don't know what is the functionality within the black box. And the application area is the credit card and default fraud or customers is not, and easy to identify patients is this or not. Recommendation system for e-commerce sites. So these were the classification algorithms and techniques. So let's check the unsupervised machine learning. In unsupervised machine learning, the data has no label, as I said before. We also do not know how many clusters or class we have. For example, we want to group customers of a company for the first time. We do not know how many customer types we have. We try to inference from the data set for better decision making. Okay, it has three techniques. In supervised, we have regression and classification. In unsupervised, we have three techniques: clustering, association, dimensional reduction, which is clustering is mainly used. Clustering technique is to group samples such that the objects within the same cluster are similar to each other than to the objects from another cluster. And in association is to discover the probability of the co-occurrence of items in a collection. And a priori and FP group algorithm used mainly in association rules. And dimensional reduction is trying to reducing number of variables of a data set while ensuring that important information is still conveyed. These descriptions are very short and very important, which exactly say what does this technique do in fact. Okay, let's review the clustering here. We have some techniques in the clustering. If it is a partitioning techniques, we have k-means and k-medoid algorithms. K-means identifies the k number of centroids and then allocate every data point to the nearest cluster, while keeping the centroid as small as possible, and each centroid is thereafter set to the arithmetic mean of the cluster it defines. Okay, here you can see we have three clusters here, and the centroids has been determined in the red star. And k-medoid, the term medoid refers to an object within a cluster for which average dissimilarity between it and all the other members of the cluster is minimal. So it tries to find the similarity. Here it tries to find the centroid, which is arithmetic mean of cluster. Okay, if we have the density-based technique here, we have two algorithms, the dbscan and optics. dbscan identifies a distinctive group or cluster in the data based on the idea that the cluster in the data space is contiguous region of high point density separated from other such clusters by contiguous regions of low point density. It draws inspiration from the dbscan clustering, which I'm describing the optics algorithm. It adds two more terms to the concept of dbscan clustering: coordistance and reachability distances. So it is a little has more performance rather than dbscan, or it is more newer. I just bring here a sample to display how does the density-based and the partitioning-based here differ from each other. In dbscan, as you can see, because of it is a density-based, the inside circle has been colored with orange, and outside circle has been colored as blue. But if we use k-means, because of the mean arithmetic, the circles has been divided into left and right side, as you can see here. And in the below picture, you can see we have 2 data points here. But in the k-means technique, this model, this sample, in fact, has 3 clusters. I just bring it here to understand what is the difference between density-based and the partitioning. Okay, in our last slide, I just want to explain the model-based techniques, which we have self-organization map, or SOM as briefly. The principal goal of an SOM is to transform an incoming signal pattern of arbitrary dimension into a 1 or 2 dimensional discrete map, and to perform this transformation adaptively in a topological ordered fashion. Transform high-dimensional dataset to 1 or more dimensional discretized pattern. In fact, it is somehow like dimensional reduction technique for when our dataset has very high dimension. For visualization, we have some problems, which SOM would be a good technique for visualizing these data sets. And the other one is neural network, or NNS brief. It has a hierarchy structure and one input and one output with multiple hidden layers that are connected together and has some weight on the connection. I just explained the neural network very briefly because it is a very comprehensive topic. I plan to describe and explain it in just one separate video. I just bring it here that to show that in unsupervised machine learning clustering and model-based we have neural network. We also have some other techniques which are rarely used. In this video, I try to explain the main techniques, algorithms, and concepts to understand what is machine learning and why we want to learn. Thanks for your attention.